what do you mean by the term energy? Energy to do some work, right? Energy, it is defined as, energy is defined as the capacity to do some work. The capacity to do work, this is what we call it as energy. Right, first we'll talk about what is a work. Earlier we have discussed it, we'll just revise this. So when you're talking about the case of work, work is defined as the product of force and displacement. The product of force and displacement. Now coming to the case of work, what is work? Is it a scalar or vector quantity? Work is a scalar quantity. Work is a scalar quantity. At the same time, the units for work is always measured in terms of joules. Work is always measured in terms of joules. Then, so when talking about the case of energy, energy we define this one as the capacity to do certain amount of work. That is what you are calling it as energy, right? And the units for energy is always measured in terms of joules again. The units for work, at the same time the units for energy, both are same. The units for work and the units for energy, both are same. At the same time, 1 joule equal to 10 power 7 ergs, wherein this is the CGS system. So 1 joule equal to 10 power 7 ergs. So when you're talking about the case of work, right? So this particular work, as long as we are talking about the case of work in the case of mechanics, as long as we talk about energy in terms of mechanics, you talk about two different types of energies. One is kinetic energy, the other one is potential energy. But basically when you talk about the case of energy, we talk about kinetic energy, potential energy, we talk about sound energy, light energy, heat energy, muscular energy, the different forms of energy. But as long as you are talking about energy in terms of mechanics, we talk about only these two, kinetic as well as potential energy. Now when talking about the case of kinetic energy, we all know that kinetic energy is equal to the symbol formula for kinetic energy, half mv square. This is the basic formula which each and everyone know. But when you're talking about the case of energy, kinetic energy, we define this, or else we state this particular kinetic energy as the energy that is possessed by a body by virtue of its motion. Energy possessed by an object, as long as the object is in motion, that particular energy is what you call it as kinetic energy. If at all the object is in motion, then only it possesses kinetic energy. Suppose that if the object is at rest, so when you say that the object is at rest, it means that the value of u equal to 0. So when the object is at rest, in that particular case, kinetic energy of the body will obviously become equal to 0 because the object is not in motion. Here you are talking about either u equal to 0, or else you can even say either v equal to 0 because the particle is at rest. Now we don't know whether the particle is at initial point or at the final point. But simple terms, you are saying that the velocity of an object is equal to 0. When the velocity is equal to 0, kinetic energy is equal to 0. The energy that is possessed by object by virtue of its motion, that is what you call it as kinetic energy. Then when we talk about the case of potential energy, potential energy is defined as, first thing, the symbol formula for this one, potential energy equal to mgh. Now this particular energy, it is possessed by any object by virtue of its position. The energy possessed by an object by virtue of its position, that is what we call it as potential energy. Now suppose that this is an object. This object is at a height from the ground, at a height of around 2 feet or 3 feet or 4 feet from the ground. As long as the object is at a height from the ground, it possesses certain amount of potential energy. The moment it is placed, suppose that, imagine this is a table. The moment the object is placed on a table or on a floor, in that particular case, the energy possessed by this one is equal to 0. If it is somewhere here, at a height of around 4 feet from the ground, it possesses certain amount of energy. Right? So energy possessed by a body because of position, you call it as potential energy. Energy possessed by a body because of its motion, you call it as kinetic energy. Now when talking about the examples for this one, right? So we'll talk about the different cases. Now suppose that you talk about the case of an object which is moving from point A to point B. Now this is point B. Now imagine that this particular point B is at a height of 10 meters. Now when the object is at the point A, exactly at the point A, the energy that is possessed by the object, is equal to 0 because the object is on the surface. Now since the object is on the surface, it is not possessing any amount of energy, E equal to 0. The moment the object starts rising upwards, right, from this particular point, you are throwing the object in the upward direction. The moment you throw the object in the upward direction at this particular point, at the point of release, the moment the object is getting released from the hand, at this particular point, it possesses maximum amount of kinetic energy. At this point, it possesses maximum amount of kinetic energy. Then, as the object keeps on moving from the point A towards the point B, the height continuously increases. When the height of the object is continuously increasing, then in that particular case, the kinetic energy of the object decreases gradually. Why the kinetic energy is decreasing? Because as the height is increasing, the velocity of the object decreases gradually with respect to height. So for any object which is projected upwards, as the height increases, the velocity of the object decreases. If the velocity of the object is decreasing, then what happens to kinetic energy? This will also just keep on decreasing. At one particular point called the maximum point, at this particular point, the point B, the velocity of the object will become equal to 0. So when the velocity is becoming equal to 0, what happens to kinetic energy? Kinetic energy will also become equal to 0. So any object which is projected upwards at the point of release, the moment you are releasing the object from the hand, it possesses maximum amount of kinetic energy. And when it reaches the maximum position at that particular point, kinetic energy of the object will become equal to 0. At the same time, if you talk about the potential energy of the object, now at this particular point, at the point A, when it is exactly on the surface, potential energy of the object is equal to 0. Why potential energy is equal to 0? Because potential energy is equal to mgh. H is equal to 0. If H is equal to 0, then potential energy is also equal to 0. Then as the height increases gradually, the height of the object is also increasing. If the height is increasing, then at one particular point called the maximum point, at the point B, potential energy will become maximum, because at this particular point the value of H is maximum. There in that particular case, when talking about the case of M, G and H, the value of M is not changing, the value of G is not changing, but what is changing? The value of H is changing. So with respect to height, as the height increases, potential energy increases. So at point B, potential energy is maximum and kinetic energy is equal to 0. But when at point A, kinetic energy is maximum, at the same time potential energy is equal to 0. Right? Now same object, right? Now it is starting at the point B. The object is starting at the point B and moving towards the point A. Now this is what we consider it as a freely falling object. Now already we have discussed that for any particular freely falling object, the value of u equal to 0. It is starting its journey at the point B, right? That is the reason why at this particular point u equal to 0, right? At the same time, for this particular object at the point B, potential energy is maximum and kinetic energy is equal to 0 as the height decreases. The value of kinetic energy increases because the value of u, the u is equal to 0, where at the point B, as the object is moving downwards, kinetic energy will increase. At the point B, the value of u equal to 0. As the object is coming downwards, velocity will increase. If the velocity is increasing, kinetic energy will also increase. So as the kinetic energy is increasing, potential energy of the object which is moving downwards will decrease. Why potential energy is decreasing? Because height is decreasing. So at this particular point, right, kinetic energy will be more, potential energy will be less. The moment the object is about to touch the ground, just before it touches the ground, at this particular point, the kinetic energy value will be maximum and potential energy is taken as equal to 0, because it's almost about to touch the ground. That is the reason why at this particular point potential energy is equal to 0 and kinetic energy is taken as maximum. So here in this particular case, whenever an object is moving from top to bottom and bottom to top, the energy, it just keeps on changing. Kinetic energy is either increasing or decreasing. Potential energy is either increasing or decreasing. Now here in this particular case, the energy of an object is getting transformed, right? Now that particular thing is what you call it as transformation of energy. That is what we call it as transformation of energy. We all know that energy cannot be created. Energy cannot be destroyed. Energy can neither be created nor can be destroyed. Energy will just simply keep on transforming from one form to other form. Now for example, a simple example. Now when I am speaking continuously for 1 hour, 2 hours, when I am speaking continuously for 1 hour or 2 hours, or else if someone is speaking continuously for 1 or 2 hours, the moment I stop speaking, I am losing certain amount of energy. Then in that particular case, that particular energy is converted to which particular form? The moment the source of sound is closed, the moment the source of sound is stopped, then the energy that was generated by that particular object for continuously for 1 or 2 hours is converted to which form? Right? It gets converted to heat. Right? So when I'm speaking continuously for 1 or 2 hours, it increases the temperature of this particular place. So the sound energy is getting converted to heat energy. So energy is getting transformed from one form to other form. Energy can neither be created nor can be destroyed. Right? Now here in this particular case, when you're talking about the case of kinetic and potential energies, right? The sum of these two energies, the sum of kinetic as well as potential energies, the sum of kinetic as well as potential energy, this is always taken as mechanical energy. The sum of kinetic as well as potential energy is always taken as mechanical energy. So if at all an object is rising upwards, for example, I take the case of a balloon, right? A balloon which is completely filled with air. The moment I release the balloon starts rising upwards. The height of this one continuously increases. Now this particular balloon, initially it was on the floor. The moment you release the balloon, the height of this one is increasing. At the same time, it is in continuous motion. When this particular balloon which is filled with air is released from the surface, the height of this one is continuously increasing. When the height of the object is continuously increasing, it means that the object is in motion. When the object is in motion, it means that it is having certain amount of kinetic energy. At the same time, since the object is at a height from the ground, it means that it is possessing potential energy. The sum of kinetic and potential is what you calling as mechanical energy. So a balloon which is rising upwards, it possesses mechanical energy. It is not possessing kinetic energy alone, it is not possessing potential energy alone, but it is possessing both. At that particular case, we simply say that a balloon which is rising upwards, this particular word is important. Suppose that if at all the balloon is lying on the floor, if it is moving on the floor itself, then it possesses only kinetic energy. If it is fixed at one particular place on the floor, it possesses zero energy. If it is moving on the floor, it possesses kinetic energy. If it is rising upwards, it possesses mechanical energy. At the same time, suppose that you talk about the case of water that is stored in a dam or a reservoir. So when you talk about the case of water that is stored in a reservoir, now suppose that this is the case of a particular reservoir wherein you are having some gates, and here water is stored in this particular reservoir. Now as long as water is stored in the reservoir, initially the dam gates are closed. You're not opening it up, right? You're just trying to store more amount of water in that. So as long as water is stored in the reservoir, the energy that is possessed by water in the reservoir is always potential energy, right? Since you're storing it up, the height of the water is continuously increasing, as a result of which the energy that is possessed by it is only potential. The moment the gates are open, water starts coming out, water starts flowing out. Now at this particular point, the moment the gates are open, potential energy will get converted to kinetic energy. Potential energy will get converted to kinetic energy. Now this is another example for the transformation of energy, wherein energy is getting transformed from potential energy to kinetic energy. At the same time, suppose that you talk about the case of bow and arrow. You talk about the case of bow and arrow. Now this is the case of a bow. Now suppose that if at all you are placing an arrow like this, and arrow is placed, the moment you want to release this particular arrow, the string of this particular bow has to be extended up to this particular point. The string of the bow has to be extended. This is what you call it as a string. The string of the bow has to be extended. Suppose that without extending the string, without pulling the string in the backward direction, if you release this particular arrow, the arrow will fall here itself near your legs. The moment you are pulling this particular string in the backward direction, the energy that is possessed by the string of the bow will be always potential. The energy that is possessed by the string of the bow will be always potential energy. This is one of the previous questions in the case of SSC, wherein the question was simple and clear. The energy that is possessed by the string of the bow is what type of energy? It is always potential. The moment you release the string, the arrow starts moving in the forward direction, right? So if at all you want the arrow to move in the forward direction, the string has to be released in this particular position. Then only the arrow starts moving. At that particular point, the energy that is possessed by arrow of the bow, or simply you can say arrow. The energy that is possessed by arrow is kinetic energy. The energy that is possessed by string of the bow, potential energy. The energy that is possessed by arrow, it is kinetic energy. Different cases. At the same time, suppose that I'll just show you some slides here. Now this is the case. Now here, when the balloon is completely filled with air, it is having certain amount of potential energy. The moment the balloon is rising upwards, air starts jetting outwards. When the air is moving in this particular direction, balloon is moving in the upward direction. At this particular point, it is having potential as well as kinetic energy. At the same time, suppose that if you see this particular case, at this particular point, when the string is absolutely straight, it possesses potential energy. And when you release this particular string, and when you pull the string and release the arrow, there in that particular case, the energy that is possessed by arrow, will be kinetic energy. At the same time, you can see the case of your pendulum. So when you talk about the case of your simple pendulum, this particular point, this is what you call it as the mean position. This point or as this particular position, that is what you call it as extreme points. Extreme positions. Already we have seen this in the case of your displacement. Mean position as well as extreme position. So every particular pendulum, it's continuously making a to and fro oscillations. While making to and fro oscillations, it continuously oscillates between extreme passing through the mean position, right? Passing through the mean position. At this particular point, when the pendulum is at this particular point, it possesses maximum amount of kinetic energy. At the same time, when the pendulum starts moving from the mean position towards the extreme point, when it is rising upwards continuously, the velocity of this particular pendulum continuously decreases. As a result of which, at this particular point, kinetic energy will become equal to 0. But since it is present at the maximum height, at this particular point, potential energy will be maximum because potential energy is mgh. So if height is maximum or displacement is maximum, potential energy will be maximum. But since at this particular maximum point it is not having any amount of velocity, kinetic energy is equal to 0. So at the extreme points, maybe this point or maybe at this point, at the extreme points kinetic energy is equal to 0, but potential energy will be maximum. Then when the pendulum is moving back to this particular point, passing through the mean position, the pendulum is coming from this point to this point, passing through the mean position. When it is coming downwards, the velocity of this particular pendulum continuously increases. So at this particular point, which are calling it as a mean position, at this particular point, kinetic energy will be maximum, but potential energy will be exactly equal to 0. Where? At the mean position. At the mean position, potential energy will be 0, kinetic energy will be maximum. At the extreme point, maybe this point or maybe this point, potential energy will be maximum, but kinetic energy will be equal to 0. Right? At the same time, you can see this particular slide. So when you're trying to hit a nail with the help of a hammer. So for hitting a nail onto any particular surface, maybe a wooden surface or any particular concrete surface, first you need to lift this particular hammer. The moment you lift the hammer, you are giving certain amount of potential energy. The moment the hammer is striking this particular nail, at that particular point, potential energy of the hammer is converted to kinetic energy. As a result of this particular nail will start moving inside or start penetrating inside because potential energy is getting converted to kinetic energy. Right? So this is the case of your energy. Then we'll move on to the next one. Right? We're talking about the case of center of gravity. So we're talking about the case of center of gravity. What is center of gravity first? Simply we write this one as CG, center of gravity. The point where the entire weight of an object is supposed to be concentrated. The point where the entire weight of an object is supposed to be concentrated, that is what you call it as center of gravity. So when talking about the case of center of gravity, now suppose that you are having two different structures. One is a perfect cubical structure like this. At the same time, you have got one more structure, something like this. Now this is, in this particular case, the center of gravity of the body, where it lies, we don't know. But whereas in a structure which is having perfect, in that particular case, the center of gravity will be lying exactly at the midpoint or the center of this particular structure. Whatever is the structure, if it is a cube, its center, cuboid at the center. But whereas for this particular irregular lamina or as the irregular structure, for this particular point, the center of gravity may be here, the center of gravity may be here, the center of gravity may be here. We cannot specify. Depending upon the shape of this particular object, the position of center of gravity will be shifting from one point to other point continuously. But wherein in this particular case, the center of gravity will be fixed at one particular point, that is what you call it as the midpoint. Right? At the same time, suppose that you talk about the case of human beings. Right? When you talk about the case of human beings, that may be a male or female, anyone. So when you talk about the case of human beings, the entire weight of the human being, right, will be lying at one particular point, which are calling it as the center of gravity. That's what you call it, the navel point or else the belly button. The entire weight of the person will be concentrated at one particular point, which are calling it as belly button. Right? Now, for instance, we see number of examples in our day-to-day life. We'll be seeing number of examples. Suppose that if at all you are carrying a bucket of water in your right hand, if at all you are carrying a bucket of water in your right hand, the moment you are carrying a bucket of water in your right hand, then obviously the body starts bending towards the left hand side. Suppose that this is a condition wherein the object is bending like this. You are trying to bend towards the other side. The moment your body is bending, the moment the upper part of the body is bending toward the other side, I am having a bucket of water in right hand. The moment I lift the bucket, obviously the body will be start bending towards the left hand side. So to what angle we can bend our body? To what angle you can bend your body? Now when you are bending your body, we must ensure that the center of gravity still lies between the legs, right? I repeat, the center of gravity of an object, the center of gravity of a person must always lie between the legs. It must not lie on the legs. This is wrong, right? As long as the center of gravity of a particular person lies between the legs, lies between the 2 feet, right, lies between the 2 foot, in that particular case the person will be more stable. As long as the center of gravity lies between the 2 foot, the center of gravity, the person will be stable. The person will be stable. The moment the center of gravity is lying on any of the legs, maybe your right leg or maybe your left leg, then in that particular case, that particular person will definitely fall down. That particular person will definitely fall down. At the same time, many of you might be aware that when you are preparing for SI or constables or any particular services, right, one preliminary check is that they ensure that both the knees are not in contact. The side part of the knee, the inside part of the knees, this particular part of the knee, right? So when you are standing straight, this particular side part of the knees must not be in contact. Why? Why? Because when you are running, suppose that if the inside part of the knees come into contact with one another, that leads to the falling of that particular person. So that is the reason why the board makes sure that both the knees, the inside part of the knees, are not in contact with one another, right? So center of gravity, what do you mean center of gravity? The point where the entire weight of an object is supposed to be concentrated, that is what you call it as center of gravity, right? For a person like me, for a person like you, right, the center of gravity must always lie between the legs. The center of gravity must always lie between the legs. Now suppose that I have got a person who is trying to climb a ladder. While climbing a ladder, right, maybe whatever is the height that you are, while climbing a ladder, you always bend your head in the forward direction. You always bend your forward direction, and then you start climbing it. We never keep our head like this and start climbing it, because the moment you bend your body or tilt your head, the moment you tilt your head in the backward direction, definitely you'll fall down. So to avoid that, what we do, you bend your head in the forward direction so that the center of gravity lies within the structure. The center of gravity will lie within the structure. Now for example, many of you might have seen the case of movies, a tall structure like this, right? This is what you call it as the Leaning Tower of Pisa. The Leaning Tower of Pisa, which is present in Rome. Right, the Leaning Tower of Pisa. The structure itself is something like this. Right from the day of construction, the structure is something like this. But even after hundreds of years, even I think it was constructed something around 200 years back. Right, even after some hundreds of years, this particular building is still standing straight. The reason is that the center of gravity of this particular building is still lying within the structure. The moment it still bends further, suppose that after 5 years or 10 years, the building is coming to this particular shape. It's coming to this particular shape. At that particular time, if at all the center of gravity lies outside the building, then definitely that will lead to the collapse of this particular structure. But as of now, this particular structure is safe and sound. It's standing still straight. The reason is that the center of gravity of this particular building is still lying within the structure. At the same time, one of the questions that appeared in your previous paper, right? You did the case of a swing. So in the case of a swing, you have got one kid who is sitting. At the same time, you have got one more kid who is standing on a swing. A kid who is sitting and a kid who is standing. Right? In this particular case, which kid is more safe? You want to find the person who is more safe. Now we all know that this particular kid who is sitting on a swing is very much safe when compared to a kid who is standing here. The reason for that is the center of gravity for this particular kid will be lying somewhere here, will be lying close to the ground. For the kid who is sitting, the center of gravity will lie close to the ground, but whereas for a kid who is standing, right, the center of gravity will be lying away from the ground, will be lying away from the ground. Now here in this particular case, the height is increasing, the center of gravity is shifted upwards, but whereas here in this particular case, the center of gravity is lying close to the ground. That is the reason why this particular kid is more safe when compared to a kid who is standing. At the same time, one of the previous questions is that when you talk about the case of a sprinter, right, sprinter, we talk about the case of Usain Bolt, or else you're talking about Hima Das, right? The sprinters. For a sprinter, where does the center of gravity lie? Whenever a sprinter is running, or else whenever a sprinter is sprinting, which means running very fast, very quick, right? So when he is in that particular sprinting position, where does the center of gravity lie for a sprinter? So for this particular sprinter, maybe for Usain Das or maybe for Usain Bolt, Hima Das or Usain Bolt, any particular person, Hima Das or else the Usain Bolt, for any particular sprinter, the center of gravity will be lying before the legs. The center of gravity will be lying before the legs. But whereas for a common man like you and me, whenever we are walking, whenever we are jogging, at that particular time, the center of gravity for common man, right, for ordinary persons, the center of gravity will be lying between the legs. For sprinters, the center of gravity will be lying before the legs. Right? So in different cases, the position of the center of gravity just keeps on changing. It just keeps on changing from point to point. For example, when you're talking about the case of a person who is walking, right? A person who is walking or running, for this particular person, the center of gravity will be lying somewhere here, right? Between the two legs, between the two legs. But whereas the same person, if he is sprinting, right? If he is bending his body a lot, and then sprinting at that particular time, the center of gravity will be lying before the legs, right? Now this is the case when you are standing straight, the center of gravity, see, you can see here, for this particular person who is standing straight, the center of gravity is lying exactly between the 2 foot, between the 2 foot for this particular person. At the same time, when this particular person is carrying a bucket or some load in his hand, his body is shifting towards the other side. His body is shifting towards the other side. At this particular point, we can see that the center of gravity is still lying between the 2 foot. Is still lying between the 2 foot. Now, you can see this particular person. Here in this particular case, you are finding 3 different cases. When the person is standing straight, the center of gravity is lying at this particular point. When the person is standing straight and raising his both the hands, at that particular point, the center of gravity is shifting upwards. Is shifting upwards, right? When he is standing perfectly straight, keeping his head downwards, then in that particular case, the center of gravity is lying a bit lower or else close to the ground. But whereas when he is standing straight and lifting both his hands, at that particular point, the center of gravity is rising upwards, right? Indicating that the person is about to lose his stability. At the same time, you can say this one. A person who is bending. Now for this particular person, the center of gravity is completely outside his body. Is completely outside his body. Somewhere, lying somewhere here. The moment this particular, if someone touches him, he will fall down. Even if someone touches him, even if a small kid pushes him from behind, he will definitely fall down. Because for this particular person, the center of gravity is lying completely outside the structure. So for this particular person, stability is very much less. But whereas for this particular person, stability is more. Because for this particular person, center of gravity is lying between the legs. And for this particular person, the center of gravity is shifted upwards. That is the reason why stability is less in this particular case. So the center of gravity, it just keeps on changing from shape of the object, from by the way where we stand, how we stand, depending upon that one, the position of the center of gravity, it just keeps on shifting continuously. It's not fixed at one particular place. It depends upon the shape of the object, whether it's having a perfect shape or whether it's having a irregular shape, whether you are standing straight, right? Whether you are bending your body completely, or else whether you are raising upwards, or else whether you are carrying certain amount of load. In all these cases, the center of gravity, it just keeps on shifting its position, right? Then, moving on to the next one, right? Then we talk about the next one, that is what you call as the centrifugal force as well as the centripetal force. Centrifugal as well as the centripetal force. So when you talk about these two forces, one is centripetal force, the other one centrifugal force. So for the case of your centrifugal force, we have got good number of examples. So we need to focus on all the examples or applications. To be more simple and clear, we can say the word applications: centripetal force as well as centrifugal force. Now this particular force, which are calling it as the centripetal force, is always acting towards the center. Centripetal force is the one which is always acting towards the center. A force which is acting towards the center, that is what we call it as centripetal force. At the same time, centrifugal force, a force which is acting away from the center. Away from center, in both these cases, these particular forces are either acting toward the center or either acting away from the center, right? Now for example, when you try to see the example for your centripetal force, so in the case of your centripetal force, right, now here you can see that a person is trying to rotate a small stone, right? He has taken a small stone, you tie a thread to that one, and when you start rotating the stone in a circular path like this continuously, you experience a certain amount of pain at the shoulder joint. You experience pain at the shoulder joint somewhere here, because for rotating the stone or the object in a circular path, this particular shoulder is providing the necessary centripetal force. The shoulder is providing the necessary centripetal force. That is the reason why you can experience certain amount of pain at the shoulder joint. At the same time, now here in this particular case, this is a case of an object where a person is trying to rotate a stone in a circular path like this, right? So here in this case, one force is acting away from the center. That's what you call it as a centrifugal force, and one force is acting towards. This is what you call it as the centripetal force. Now as long as these two, centrifugal and centripetal, both are balanced, you can rotate this particular object in a circular path without any problem, right? Suppose that you take a small thread and stone and rotate it continuously. Suppose that if you start rotating your wrist, you stop rotating your wrist. I'm taking a stone and a thread, rotating like this continuously for some time. After rotating for around 30 seconds or 40 seconds, you stop the movement of the wrist. Stop the movement of the wrist and then see what happens. The complete thread will be wounded. The complete thread will be wounded to your hand, because you are not providing the necessary centripetal force. That is the reason why the thread is completely wounded to your hand, or else the thread may completely break away. Whenever you are stopping it, whenever you are rotating with a very high speed and stopping it suddenly, the thread may break and the stone may move in an opposite direction, right? So there in that particular case, the centripetal centrifugal forces are balanced. As long as they are balanced, you can rotate them in a circular path. At the same time, whenever an object is moving in a curved path, in order to move an object in a curved path, right, the centrifugal force, it tries to protect that particular thing. Centrifugal force is the inertial force which a particle or an object experiences in a circular path. It's an inertial force which is being experienced by an object in a circular path whenever you are moving in a curved path, right? This particular centrifugal force, it tries to balance that one, because one particular force is acting toward the center. One particular force, this is a curved path like this, right? One particular force is acting toward the center and one particular force is trying to push away, as a result of which the movement of vehicles on this particular curved path is very much safe. You can do it without any problem, because the centripetal force and the centrifugal force both are balanced. But the thing is that what we need to remember is that in the case of these forces, right, centripetal and the centrifugal forces. First, when talking about the case of your centripetal force, now we know that Sun and the remaining 8 planets. We know that Sun and the remaining 8 planets. We know that Earth is continuously rotating. Earth is continuously rotating around the Sun. Right? This particular movement of Earth around the Sun, the movement of all the 8 planets around the Sun, is continuously taking place from hundreds and thousands of years. Right? Without any problem. Without any problem. Earth is not moving away from the Sun. At the same time, Earth is not moving toward the Sun. Now, this is the place where you find a Sun. And in these particular orbits around the Sun, all these orbits are elliptical orbits. You have got Mercury here, you have got Venus here, Earth here, Mars, right, Jupiter, Saturn, Uranus and Neptune. You have got all the 8 planets. All the 8 planets moving around the Sun in elliptical orbits like this. All the 8 planets moving around the Sun in elliptical orbits. Now when these planets are moving around the Sun in elliptical orbits, at that particular point, the centrifugal force and the centripetal force both are balanced. As long as these two are balanced, it just all these planets, they keep on moving in circular paths. At the same time, these planets are moving around the Sun in circular path, and the necessary force is given by the Newton's law of gravitation. In order that all the 8 planets are continuously moving around the Sun in elliptical orbits, the necessary force is provided by the Newton's law of gravitation. In order that all the 8 planets are continuously moving around the Sun in elliptical orbits, the Newton's law of gravitation provides the necessary required force. At the same time, when you're talking about the case of centrifugal force, right, now this particular force, centripetal is the one which is acting away from the center, which is acting toward the center. Centripetal is the one which is acting toward the center. At the same time, centrifugal is the one which is acting away from center. At the same time, centrifugal force, the most important thing is that centrifugal force is a pseudo force. Now, what do you mean by the term pseudo force? Right? It indicates, this particular word pseudo force, it indicates that centrifugal force may exist or may not exist. Centrifugal force may exist or may not exist. But if at all, if it exists, there in that particular case, the centripetal force and the centrifugal force both will be always equal. At the same time, both will be always equal. At the same time, both will be equal and opposite. The centrifugal and the centripetal forces, they're always equal. At the same time, they're always acting in opposite directions. One is acting, centripetal acting toward the center, centrifugal acting away from the center. These two will be always equal. At the same time, both will be always acting opposite to one another. Now we'll move on to the examples or the applications of centrifugal force. So when talking about the case of your centrifugal force, where do we find or where do we use this particular centrifugal force in our day-to-day life? Right? The first and foremost thing, the working of mixer. Whenever you are operating your mixer, or else whenever you are operating grinder, the working of mixer, grinder, washing machine. At the same time, the preparation of butter from buttermilk. Whenever you are extracting butter from buttermilk. At the same time, the making of honey or else the extraction of honey. So from where do we get honey? From honeycomb or else from beehives. From honeycomb, or else you can even call them as beehives, the place where all these particular honeybees stay, that is what you call as the honeycomb or beehives. The extraction of honey from honeycomb, it's again based on one particular thing called as centrifugal force. At the same time, the extraction of butter from buttermilk. At the same time, the preparation of sugar from molasses. The preparation of sugar from molasses. All these particular things, they are based on one particular thing called as centrifugal force. All these things, they are based on one particular thing called as centrifugal force. Right? A force which is a pseudo force. At the same time, a force which is acting equal and opposite to. Equal, at the same time opposite to centripetal force. That is what you call it as centrifugal force.